Yes, so I will be talking today about aerosol transmission and airflow, air conditioning, particularly in indoor environments, but I'll also address Martin's question as well as far as aerosol generation from the swimming pool water. So we're going to look at this from a beginning to end sort of analysis in terms of starting with the viral output activities. That is, what kinds of activities are there, respiratory activities or others that produce viral output from people. We'll take a look at the different droplet sizes briefly to distinguish between the large droplets and aerosols and what's the difference there and why does it matter. That's related to the different routes of transmission of the virus. And then we get into a little bit of detail on the velocity and concentration as a function of distance, because that's really the basis of the physical or social distancing. And last, we will talk about some mitigation, but the purpose of this talk is to give you enough information in the detail of how this works in terms of transmission so that the policies from this conference, for example, and recommendations can be consistent with that, even if it's additional mitigation beyond what I will talk about. Okay, so first let's start with the viral output activities. As you can see, there's a list here where don't have to worry too much about the velocities and angles. We'll mainly focus on the dose that comes from the different activities. And you can see that normal breathing, and that's breathing that is not related to, panting and heavy exercise. It's just regular, breathing in and out as one would normally do. It's very low risk. And the reason is that there's very few, both larger droplets and aerosol produced during normal breathing. There is water vapor, but that's different. The virus is not in water vapor, which is a gas. The virus is only generally expelled in liquid water, which would be either larger droplets or aerosols. So breathing is of low risk. Moderate exercise has some moderate risk, as I show, but what we're going to focus on to some degree is talking, talking, because that's the most common activity that people perform, which has risk because of the virus coming out of their mouths. Singing is, of course, even higher. And coughing, people think of coughing as being particularly bad, but in fact, a cough is equivalent to about 6 seconds of talking. So unless you're coughing continually, talking is actually often worse. Now, if you're very close to someone and they're coughing, then obviously some significant amount of larger droplets can get into your face. But generally speaking, at regular normal distances, particularly those that are recommended for social distancing, coughing is not nearly as much of an issue as having someone have a conversation. Sneezing is uncommon with COVID-19. Sneezing produces a huge amount of particles coming out. It's unclear exactly how much is in the aerosol fraction, but again, sneezing is uncommon with COVID-19, so not as much of a concern to talk about. I also listed and I added the fecal part, which was part of what was used for the calculations for Martin in what I had given to him. So let's talk about the droplet sizes. The larger respiratory droplets are those that are typically more than about 10 micrometer in diameter. They drop faster with gravity until they get to a terminal velocity. So you can see here these larger red ones drop first, these medium-sized green ones then drop a little further, and some of these, I think they're bluer or gray, but some of these other ones that are either smaller droplets or in aerosol size go ahead and reach the other person for inhaling. The larger droplets, if the larger droplets do get to somebody, like getting to your mouth, even if your mouth was, say, open at the time the droplet was coming by, they're going to hit the back of the throat. They're not going to go around the bend in the throat down to the esophagus or to the airway, actually, because you're going to be breathing at that time. That won't happen because larger droplets have too much momentum, and they don't follow the airstream, so they can't turn. And similarly with the nose and the eyes, they're just not going to go around the bend, and that means that the infection will be the upper respiratory system. And for this virus, SARS-CoV-2, the infective dose required for the upper respiratory system is pretty high relative to the lower respiratory system. So the smaller droplets, or also known as aerosol, that are less than 10 micrometer, especially those less than 5 micrometer, they follow the exhaled jet stream. So when you breathe out, in particular talking, you're vibrating your vocal folds and creating aerosol, as well as smaller droplets. The aerosol follows the jet stream, so that doesn't fall off. It takes way too long to fall off. So it follows the jet stream, and then the other person on the receiving side takes a breath in and inhales it. And that inhaled air follows all the way down deep into the lungs. And that's why you can get infected more easily in the lungs with aerosols. And as I mentioned, the infective dose for aerosols is significantly lower compared to the 300,000 for the upper respiratory tract that Martin had in his presentation. The infective dose for inhaled aerosol is only about 900 or 800. So this is what we're going to be focused on and talking about, is these aerosols. So for routes of transmission, we talked about the upper respiratory route, which is from larger droplets at closer distances. There's also fomite transfer, that's from surfaces, and that you then touch your mouth, nose, and eyes from typically your hands. And then there's the lower respiratory tract, which is where the smaller droplets and aerosol at both close and far distances occur, and we'll talk about both. And then there's the fecal to oral route as well, which Martin talked about in the pool a little bit, but I'm going to focus mainly on the lower respiratory tract. The fecal to oral route is very unlikely due to the low fecal concentration of the virus, relatively speaking, compared to some other pathogens. But especially the high required oral infective dose, and then there's the significant dilution as well as disinfection in the water. So let's talk about the lower respiratory tract and the aerosol risk. So here's a graph that shows the fall off of the velocity and concentration. They both fall off in the same shape. I'm showing the velocity in terms of the numbers here, but the concentration also falls off this way. And it falls off with distance, inversely with distance, as 1 over x. You can see it for yourself if you, you don't need expensive equipment. You can do this and test with distance. You can test masks and so on. If you just, you can wash your hands after you're doing the experiment, but you can cough in or speak into your hand very close, putting it to your face, then pull your hand away, and you can feel how quickly the velocity drops off, even for coughing similarly. You could do it with a candle at a distance as well. So there's ways at home you can experiment yourself to see. You don't necessarily need expensive lab equipment. And notice that it falls off very quickly in the first foot, third of a meter. It's almost about a factor of 10. And then it continues to fall off after that. Every doubling a distance will go in half. Also notice that coughing outputs at a higher velocity than speaking. One cough, as I mentioned before, is equivalent to 6 seconds of speaking. The fastest fall off is very close in. This is why you do not want to get within a foot of another person. If you're in bars and clubs where it's very noisy and it's crowded, people tend to get close together and they speak more loudly, and that is much, much higher risk. I mean, an order of magnitude or more, which is why it's such a problem and why distancing is important, indoors in particular. A rough calculation shows that if you have an average viral load person talking for about 10 minutes and they're only about a foot away, that there's a good chance that they're going to infect the other person. And if you happen to be speaking with someone who has a high viral load, the viral load varies by people a lot, orders of magnitude at times. A high viral load person, 100 times viral load can infect someone literally in seconds if they're speaking closely. Okay, so this is again why distance is important, but also masks. Masks have another factor of 10 on each side, up to approximately 5 to 10, and the product of the two masks reduces risk significantly. Okay, now let's look at that similar graph, but over longer distances. Now this is a logarithmic graph so that I can show long distances more easily, and you can see the linear relationship with having half the velocity and doubling the distance. This dotted line is where the typical ambient airflow of air-conditioned areas is, and indoors this is talking about, and that's 0.1 meters per second. And what you can see is it's higher if you open the windows, for example, let fresh air in, even higher if you have ceiling fans. But the jet from talking moves with the ambient air at about 1 meter, meaning that you have a jet coming from your mouth. It's slowing down in velocity pretty rapidly, and when it gets to about 1 meter away, the ambient air in the room is going to have more of an influence than the jet stream itself, and it'll tend to not only be diluted from distance, but it'll tend to mix much more thoroughly and be much lower risk beyond that for talking. However, for coughing, and this is happening at about 5 seconds it takes to get to about 1 meter away. For coughing, it's a further distance of about 7 meters, which is this is partly where the basis of the 2 meters comes from, except that it's coming from larger droplets in the fall off. But the point is that aerosols too, there's lower risk as you're further away. So the similar kinds of social distancing help there. Of course, aerosols have other issues too, which we'll talk about, which are beyond just distance. Now you can see that opening a window or turning on circulatory fans shorten these distances, which helps diffuse and dilute the virus concentrations more quickly. So you can see within about 1/3 of a meter for talking, and perhaps 2.5 meters for coughing, significantly better than what it was before. Here's another risk, though, that's unique to aerosols. Aerosols can build up the virus in an enclosed space. One average viral load infected person, if they're talking continuously for a couple of hours in a fairly small, room, 4 by 4 by 3 cubic foot room, this would be like a typical room inside a home, for example. So, not a huge room, but not a small room, kind of average size. And even if you have 6 air changes per hour, a rough calculation shows that about 5 to 10% of the people could get infected, and that's from an average viral load person. If you have, this is mostly from the cumulative dose exposure, because you're just, breathing in and out so much, and you're just accumulating a lot of virus. A high viral load person would literally just take only a few minutes in this same kind of a scenario. And this is where for example, the choir and other in Hong Kong office and so on, this is how this can happen. You have it's a little larger environment, but it is enclosed space without a lot of good air exchange, and you have somebody that has on the higher end of a viral load, and they're talking a lot or singing, which singing produces a lot more, as I showed you before. That's how many people can get infected, and these are just approximate examples. So what about mitigation? Okay, to the extent possible, keep people outdoors rather than indoors. Outdoors is much safer because there's no buildup at all, because there's no boundaries to build up. And also tends to be a lot more wind or air movement outdoors. And so the other effect that I showed earlier, where the diffusion happens at shorter distances, or starts to happen at shorter distances, is a benefit. Keep physical distance, particularly indoors. I mean, it's good to do outdoors as well, but it's especially important indoors. Improve the air exchange indoors. So if you have to be indoors, don't just recirculate the air, okay? In order to prevent the buildup, open the doors and windows when possible, or use exhaust fans. Limit the talking indoors. This is such a simple one. So having signs that indicate, if you want to have a conversation, please go outside. Obviously, you can't eliminate all talking because it's necessary at times, but if you limit it, that will significantly reduce the risk, because if you're just breathing, you have almost no risk. I mean, if both parties are breathing, if there's nobody talking, right? Enforce mask use where practical, of course. That has the mask use is a tremendous benefit, but you can't always wear a mask everywhere, such as inside, at the pool or in a shower. And then, of course, the next presentation we'll talk about cleaning surfaces, which is also important. But I want to emphasize that if you only had time or money to do one thing, making sure the air is clear first, and then do your surfaces. You should do both, but obviously, if you only had time for one, please make sure the air is clear. And then there's a list of references that I used for this presentation, and there's additional ones as well. And you can contact me for anything more information about this presentation or other details about SARS-CoV-2 transmission. Thank you very much.